Hello students, in the today's lecture we will study Faraday rotation principle, and in that we will study Gyrator, Isolator and Circulator principle. So in this Gyrator, Isolator, Circulator, generally ferrite material is used. So ferrites are non-metallic materials with resistivity rho nearly 10 raised to 14 times greater than metals and with dielectric constant epsilon r around 10 to 15 and relative permeabilities of 1000 order. These are oxide based compounds. So ferrites are oxide based compounds having general composition of the from MEO, Fe2O3, that is a mixture of metallic ferrite and ferric oxides. Ferrites have atoms with large number of spinning electrons, resulting in strong magnetic properties. These magnetic properties are due to magnetic dipole moment associated with electron spin. So these are raw materials used for making micro components. So ferrite is a raw material and used for making micro components, and it has a irreversible property. So what is meant by irreversible? Whatever you have the property in forward direction, it will not be in the reverse direction. So it is a irreversible property. It has a irreversible property. Now we are going to tour different micro component where these ferrite materials are used. So these ferrite materials used devices are generally gyrator, isolator and circulator. All these three devices operates on using this ferrite material, and these devices operates on basic principle, that Faraday rotation principle. So what is Faraday rotation principle? So in oral exam, this Faraday rotation principle is asked. So if a circularly polarized wave is made to pass through a ferrite rod, so this is a circularly polarized wave and which is made to pass through a ferrite rod which has been influenced by an axial magnetic field B. This is an axial magnetic field B. Then the axis of polarization gets tilted. So this axis of polarization gets tilted in clockwise direction. And the amount of tilt depends upon the strength of magnetic field and geometry of ferrite. So statement is easy. From this figure you can recall this statement. So when circularly polarized wave is made to pass through ferrite rod by an axial magnetic field, then axis of polarization gets tilted in which direction? Clockwise direction, and the amount of tilt depends upon strength of magnetic field and geometry of ferrite. Then first devices which operates on this Faraday rotation principle is a gyrator, and in this gyrator generally ferrite material is used. So gyrator is a non-reciprocal ferrite device. It is a two-port device that has a relative phase shift of 180 degree in forward direction and zero phase shift in a reverse direction. The systematic symbol of a gyrator is as shown in this diagram. When signal is transmitted from port 1 to port 2, then it offers a phase shift of pi radian, and when signal is fed to port 2, it offers a zero phase shift. Hence it is also known as a differential phase shift device. Okay, so two-port device that has a relative phase shift of 180 degree in a forward direction and zero phase shift in a reverse direction. Okay, so this is a gyrator. Then gyrator construction. Gyrator consists of circulator to rectangular waveguide transition, both at the dominant mode. A twin circular ferrite rod tapered at both ends is located inside the circular waveguide. So twin circular ferrite rod, when tapered at both ends, is located in a circular waveguide surrounded by permanent magnets, which generates a DC magnetic field for the operation of a ferrite. So how this gyrator is constructed? twin circular ferrite rod tapered at both ends, located inside the circular waveguide, surrounded by permanent magnets. A rectangular waveguide twisted by 90 degrees is connected by input and reduces attenuation and also provides smooth attenuation of a polarized wave. Circulator and isolator. So both microcirculators and microisolators are non-reciprocal transmission device that use the property of Faraday rotation in the ferrite material. To understand the operating principle of circulator and isolator, let us describe behavior of ferrite in a non-reciprocal phase shifter. So first we will consider a circulator. So what do you mean by circulator? A microcirculator is a multi-port waveguide junction. So this is a multi-port waveguide junction. This is a port 1, this is port 2, this is port 3, and this is a port 4. So multi-port waveguide junction in which wave can flow only from nth port to n plus 1th port in one direction as shown in figure. Okay, when wave is fed to port 1, it comes towards to port 2 and again goes to port 3 and then will get at a port 4. Although there is no restriction on the number of ports, the 4-port microcirculator is the most commonly used. So we'll study working of circulator. Working of circulator is based on principle of Faraday rotation. All the ports 1, 2, 3 and 4 are oriented such that electric field of transmitted signal couples to these ports successively after going through a rotation of 45 degree in a clockwise direction. So 45 degree in clockwise direction. So as shown in this diagram, one type of a 4-port microcirculator is shown, and it is a combination of two 3 dB side hole directional couplers, two 3 dB side hole directional couplers, and a rectangular waveguide with two non-reciprocal phase shifters. Okay, so two phase shifters as shown in this diagram, and two directional coupler, that is coupler 1 and coupler 2 are there. And if you observe here, this is a phase shifter and this is a phase shifter, and this is a primary guide and this is a secondary guide. If you observe, if we give the input to the port 1, then at the output at the port 2 wave is in phase, that is a 180 degree phase shift. But in port 3 port 4 output, if you observe, there is a no they are not in the same phase but out of phase, that is a 270 degree and 90 degree. So each of the two 3 dB couplers in the circulator introduces a phase shift of 90 degree, and each of the two phase shifters produces a certain amount of phase change in a certain direction as indicated. Since the two waves reaching at port 4 are out of phase by 180 degree, and the power transmission is from port 1 to port 4 is a 0. In general, differential propagation constant in two directions is omega 1 minus omega 3 is equal to twice of m plus 1 into pi radians, and omega 2 minus omega 4 is equal to 2n pi radians per second, where m and n are any integers including zeros. And next is a 4-port circulator. So previous diagram we have observed there are two phase shifters and two directional couplers are used. Another example is a 4-port Faraday rotation circulator diagram is as shown in this figure. Power entering to the port 1 travels along the magnetized ferrite. This is a magnetized ferrite. The direction of the E field vector gets rotated by 45 degrees. So electric field rotated by 45 degrees. Therefore, power entered at port 1 appears at the port 2. Okay, power appears at the port 2. The power cannot be coupled to port 4 because port 2 and port 4 are 90-degree out of phase. So this port 4 and port 2 are 90-degree out of phase. Similarly, port 3, this port 3 is coupled to port 4 and port 4 is coupled to the port 1. So this is a basic diagram of a 4-port circulator. When wave is entered to the port 1, it is pass through this ferrite and rotated by clockwise direction in 45-degree. So when we will given to the port 1, we will get at the port 2, then we will get at the port 3, and then we will get at the port 4 in a clockwise direction. Then next is a 3-port circulator. A 3-port circulator is a symmetrical Y-type junction of 3 identical waveguides with an axially magnetized ferrite post placed at the center. Okay, next slide shows the 3-port circulator. The ferrite post is magnetized by a static magnetic field along the axis. It provides the necessary non-reciprocal property. The junction can be matched by placing suitable tuning element in each arm. So this is a 3-port circulator as shown in this diagram, and it is an essential component used to isolate the input and output in a negative resistance amplifier. 3-port circulators are also used to couple a transmitter to various receivers. The next is a 4-port circulator using magic T. A 4-port circulator can be constructed by using two magic T's. So this is a two magic T structure and phase shifter as shown in this figure. So sometimes in exam explain 4-port circulator using magic T. Such type of question is asked in same. So you have to draw this diagram, and 180-degree phase shift is connected as shown in this diagram. So diagram is important. You can write down from this diagram. Two magic T's and 180-degree phase shift is the phase shifter is used. The next component is the isolator. An isolator is a non-reciprocal transmission device that is used to isolate one component from reflection of other component in the transmission line. So in microwave communication, this isolator plays very important role. That is, an ideal isolator completely absorbs the power for propagation in one direction and provides lossless transmission in opposite direction. So isolator is usually called as a uniline. So in oral exam, why isolator is called as a uniline? Because ideal isolator completely absorbs the power for propagation in one direction and provides lossless transmission in a opposite direction. So isolators are generally used to improve the frequency stability. So this word is important. It provides frequency stability of a microwave generators such as klystrons and magnetrons, in which the reflection from the load affects the generating frequency. So if you observe in our practicals, after the klystron, this isolator is a place. Why? Because it provides the frequency stability. In such cases, the isolator placed between the generator and the load prevents the reflected power from unmatched load from returning to the generator. As a result, the isolator maintains the frequency stability of the generator. This is a Faraday rotation isolator as shown in this diagram. Input waveguide is here, and this is a resistive and reflective wave factor as shown in this diagram. This is direction of rotation, and this is a magnetic field as shown in this diagram. There is 45-degree clockwise rotation as isolator operates on the Faraday rotation principle, and this is the output waveguide. From this diagram, we will study basic operation of a Faraday means isolator by this Faraday rotation principle. So isolator can be made by inserting a ferrite rod along the axis of rectangular waveguide as shown in this diagram. So how isolators are made up? by inserting a ferrite rod along the axis of rectangular waveguide. The input resistive card is in the YZ plane, and the output resistive card is displaced 45 degrees with respect to input card. The DC magnetic field, which is applied longitudinally to the ferrite rod, rotates the wave plane of propagation by 45 degrees. So this as shown in this figure, DC magnetic field which is applied longitudinally to the ferrite rod rotates the plane rotates the wave plane of a polarization by 45 degrees as shown in this diagram. The degree of rotation depends on the length and diameter of the rod and on the applied DC magnetic field. An input T10 dominant mode is incident to the left end of the isolator. Since T10 mode wave is perpendicular to the input resistive card, the wave passes through the ferrite rod without attenuation. The wave passes through the ferrite rod without attenuation. That is, when circularly polarized wave made to pass through this ferrite rod, axis of polarization gets tilted in clockwise direction. So if you observe, axis of polarization gets tilted in clockwise direction, and this device operates on Faraday rotation principle. So isolators can be made by inserting a ferrite rod along the axis of a rectangular waveguide. So as shown, as explained here, and this explanation already explained in the previous slide. Summarized explanation is given in this slide, so we can skip this slide. So the wave in the ferrite rod section is rotated clockwise by 45 degrees and is normal to the output resistive card. As a result of rotation, the wave arrives at the output end without attenuation at all. So wave arrives at this port without any attenuation. On the contrary, a reflected wave from output end is similarly rotated clockwise 45 degrees by ferrite rod. However, since the reflected wave is parallel to the input resistive card, the wave is thereby absorbed by the input card. The typical performance of these isolators is about 1 dB insertion loss in forward transmission and about 20 to 30 dB isolation in a reverse attenuation. So this is a basic explanation of isolator. So in summarize, we can explain isolator as it is a uniline. It provides frequency stability and it operates on a Faraday rotation principle, and DC magnetic field or when circularly polarized wave made to pass through this ferrite rod, then axis of polarization gets tilted to clockwise direction and we will get the output without attenuation or any distortion. So in the isolator, first parameter is insertion loss. Insertion loss is defined as this is a ratio of 10 log of P1 to the P2, where P1 is a power launch at input port and P2 is a power received at the output port. The next parameter is isolation. Isolation is defined as a ratio of 10 log of P2 dash by P1, where P1 dash is power at input port and P2 is a power launch at the launch from a output port. Then next is the application of isolator. Generally, isolator is used as previously mentioned in the klystron and magnetron to improve the frequency stability. So this is an important function of isolator. It provides the frequency stability. So in this lecture, we have studied Faraday rotation principle. So and devices which operates on Faraday rotation principle. Okay, so in that generally ferrite material is used, and which are these devices operates on which principle? Faraday rotation principle. So keep in mind Faraday rotation principle, then gyrator working or construction. Then next, circulator. We have studied 4-port circulator, 3-port circulator, circulator, that is using the magic T. So in exam, that is a question is asked on isolator or circulator, and also in oral exam state Faraday rotation principle. So such type of questions are asked. Why isolator is called as a uniline? Okay, what are the applications of isolator? Okay, so isolator provides the frequency stability. So we have completed here this third chapter. Okay, thank you.